All right, so we shall look at some sketches to the problems given in the earlier video. The problems are fairly straightforward if you have followed the videos carefully. So I think I'll just provide the sketches of them. So problem 1 is very simple. I shall not solve it. I have shown the golden rule level of savings for a general Cobb-Douglas function in the last video. So this should not be very difficult. The answer is, of course, 0.3. The golden rule level of savings S is equal to 0.3 or 30%. And the first two questions should be fairly simple as well. So question number 2. Let's look at question number 2. Another fairly simple question. Consider an otherwise identical Solow model of growth where the entire income is consumed. So savings is 0, which implies that K dot is equal to Sy minus n plus delta K is just equal to minus n plus delta K, which is always negative. Right? So to look at this diagrammatically, you have this, which is n plus delta K, and well, you don't have Sy at all, and the only steady state, of course, is this, because this equals to 0 implies KSS is equal to 0. So the only steady state is the trivial steady state of KSS 0. Is it globally stable? Yes, it is in fact globally stable, because suppose you're here, right, at K1, n plus delta K exceeds Sy, and so you depreciate and come somewhere here, 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 and eventually you're back to 0. How do real wage and real rental evolve over time? So just to remind you, small r is equal to f dash k. Wage is equal to f of k minus k f dash k. Okay, now this is something we have actually not looked at earlier. Okay, so how does real rental evolve over time? It's fairly obvious. So over time, small k is going down, which implies f dash k is going up, which implies real rental is going up. But what about real wage? We don't really know, at least from this equation or this result. We don't know from this result whether real wage increases or decreases as k changes, or if there is even a solution which is not ambiguous to that question. But let's try that out then. How does wage evolve when small k changes? So this is equal to f dash k minus f dash k minus k f double dash k. So this is equal to minus k f double dash k, which is positive, right, since f double dash is negative. So when k falls, real wage also falls. So over time, real rental increases and real wage falls. All right. Fairly simple question, but I think this question does give you a very interesting and important result, which is that over time, real rental and real wage evolve in separate directions, and the specific directions depend on how k is evolving. Okay, third question. Again, a very simple question. Okay, think of BOP equilibrium or national income accounting. You know that this is true. There's no government by assumption here. This implies that I, which is gross investment, is y minus c minus nx. Now, this is s minus nx, which is sy minus my. So you have s minus my. And so small k dot, which is equal to s minus m small y minus n plus delta k. This is the final result. For the Cobb-Douglas function, you know that KSS is in general equal to S by n plus delta 1 by 1 minus alpha. Here instead of S you have S minus n. You can do this in full yourself. Fairly simple question. Alright, next one. Question number 4. This is again a very simple question if you have watched the earlier videos carefully. So G is equal to sigma y, C is equal to phi minus lambda sigma y. Now y equals C plus I plus G, so I equals S minus G, which equals just equals y minus C minus G, which equals y minus phi minus lambda sigma y minus sigma y. Taking capital Y common, you have this, right? Let small s equal this. Okay. Now the remaining part of finding out k dot and steady state for any given production function is just how you always do with s, and then replacing the final answer with this. This is in fact another technique you should probably get used to, which is when you have a really complicated expression and a lot of algebra in between, just take that expression to be some constant, do the algebra and replace the substitution in the end. The question asks, find the sign of dkss by d sigma. Okay. Now we know dkss ds is positive, right? Therefore dkss d sigma, now dkss d sigma is equal to dkss by ds into ds by d sigma, chain rule. So this is equal to dkss ds into lambda minus 1, right? Now this is clearly negative and this is positive, which implies dkss d sigma is negative. Done. Fairly simple again. Next. Question 5. This question looks difficult but is really not very difficult. So this is a production function which does not satisfy the general Solowian assumptions. It's not really concave in the sense we usually talk about. It's not even a smooth function in general. So you have y equals min akbl. So y by L is min of ak by L comma b, which is equal to min of small a into small k b. So, and just to write this more carefully, this is equal to ak and this is equal to b when ak greater than b. So let's graph this. It's fairly simple. Till k reaches b by a, you have a smooth linear function stopping at b, because when ak equals b, this whole thing is equal to ak and it's equal to b. Beyond that, it's just equal to b. So this is the function. When does this have a positive steady state value of k? So b. B and c are fairly simple again. So you just multiply this by s to get a function that looks the same, but it's just scaled by scaled by s. So you have this ky b by a. So if you look at steady states, so there are three cases here. When this is n plus delta k, no positive steady state. When this is n plus delta k, you have infinitely many steady states, some of which are indeed positive. And when you have this, then also you have a positive steady state value here. So now the third question, is there unemployed workers or capital at this point? So note, at this point there's too much capital per worker, right? Which means you're beyond this point. So okay, let's just look at it this way. So you have AK less greater than B, which means AK is greater than BL, which implies that, okay, so the production function is minimum of the two, right? And you have too much capital, which means the capital beyond this point are unemployed, right? Because they are there in the factories, but there's no worker to work on them, given the production function. So you have unemployed capital here. Under what condition are both capital and labor fully employed? Obviously that's only true here, because if you're on this parts, then there is too little capital, which means labor is unemployed, and on these parts there is too much capital. So this is the only point where both labor and capital are fully employed. So the condition for that is obviously that these two lines are coincident. So the answer to C is n plus delta should be equal to A. Under this condition, both labor and capital are fully employed, as long as this is the steady state you reach and not any of the other infinite steady states which are available when n plus delta equals A. Alright, question 6 is something you have to think more deeply about, but it's not a very difficult question. So a country has two parts, a city and the districts. Those living in the city own all the capital and save or invest proportion S of their income. Labor is supplied by the districts who consume everything they earn. So let's go back to the basic premise behind the Solow model. Where is gross investment coming from? It's coming from savings. In this economy, what are savings equal to? They are equal to the savings of the city folk. Okay, let's write it this way. I is equal to S, which is equal to S of city folk, right? Which is equal to S into income of the city folk. So what is the income of the city folk? Remember, income is generated from the factor market. There are two factors of production, capital and labor. All of labor is supplied by those in the districts, which means the only source of income for those in the city is the capital they own, and they own all of it. So what is their income? All right, let's look at R. Before we did everything we did with the intensive form production function, remember that real rental is equal to MPK. Now, for a Cobb-Douglas production function, which we have here, that is equal to alpha K alpha minus 1 L1 minus alpha. Therefore, income from K, which is equal to R into K, is equal to alpha K alpha L1 minus alpha, which is equal to alpha Y. Right? Therefore, I equals S into Y of city is equal to S alpha Y. Everything else now is familiar. K dot, which is equal to I minus delta K, is equal to S alpha Y minus alpha K. Small k dot, which is then equal to S alpha small y minus n plus delta, based on the familiar algebra we have done earlier, is equal to S alpha K alpha minus n plus delta K, and you can solve this just as you have in the standard case. The final result is that the steady state level of capital per worker is this.